Hello, geometry. It's going to be our last YouTube video. We are going to be looking at combinations and permutations. We have just a few things. And then next week's our last week, which we're not really going to do very much. We're just going to do some Zoom meetings, which are going to be review. So this is going to be the last of the new content. It is in the Dropbox folder, so the student journal is in there. If you want to follow along with some of the problems we're going to do or talk about. Before we get into these things, I want to talk about some things you've probably heard of that I'm not sure is in this video. But a factorial, so like factory, with Oriole at the end. My phone's doing that. But a factorial is just a multiplication. So it's multiplication. And we write it using an exclamation point. I like saying exclamation point. So like 6 factorial, we'd say this is 6 factorial here. 6 factorial is just 6 times all the numbers below it in order, including the 1, even though really you're multiplying by 1, it doesn't mean anything, but you include the 1. Right? And so we would just multiply all of those together and we get a number. It's going to be, usually these factorial numbers are going to be really big because, well, it's multiplication. So we get 30, right, times 12, times 2, times 1. So this is just 360 times 2, which is 7. Okay? And so that's a factorial. We're just using an exclamation point to represent the fact that we're going to multiply all the numbers lower than that. And you can do this for any whole integer. Non-negative numbers, the factorial could be negative, but we're not going to do like negative 6 factorial. It would be 6 factorial, and that 6 factorial would be negative. Okay? So this is useful for combinations and permutations. And if we go to the student journal, page, this textbook pages for 12.5, and this is the student journal. It's a couple pages in. We're not going to talk about these examples till later. Okay. So a permutation is just the total number of objects. So the textbook would say in its definition that a permutation is an arrangement where order matters. So the two things that we need to remember for combinations and permutations is that for permutations, the order matters and is important. Each order is different. And for combinations, order does not matter. So for the permutations of ABC here, the order that we can write them in, these are all different. Whereas in a combination, they'd all be the same because we're just looking at the set. Okay. So a permutation in our student journal is a set of things where the order matters. In factorial, we talked about factorial, just multiplication. In combinations is order does not matter. Now, say we have 20 things, and we want to talk about how many ways can we order them. We have 20 people and we want to line them up. How many different ways could we put them in an order? It would be 20 factorial. And the way to think about this is 20 factorial. The way to think about this is there are 20 different people. There are 20 different people. So for my first position, I have 20 choices. For my second position, well, I've picked one of those 20 people. And now I have 19 different people to pick. And then for our third thing, then there's 18. And then we're seeing here that it's the factorial. And we're multiplying because We're adding up all the possible options, and when we multiply, it's really just addition. Okay, and then once we get to the end, once we get to the 20th thing, well, there's only one person left. We picked all the other 19 people. And so that's how we would get our. Okay. So if we want to arrange 20 people on a line, we would multiply all these numbers together. We would use a calculator. If you just go in Desmos and do 20 exclamation point, it will calculate it for you. You have to actually do the individual multiplications. So this will be 20 factorial like this. And 10 to the 18th just means that behind that decimal point on the 2 here, there's 18 zeros. So this is a really big number because we multiplied a lot of big numbers together. Okay. A combination, order does not matter. So, and usually here there are more objects than the things in the combination. So like we have 20 objects and we want a combination of 4 of them, we would use this formula. So, and this notation here tells us some things. N is the number of things, R is the number, N is the number of total things, R is how many we're picking. And so when we pick 4 objects, 2 at a time, we just plug the numbers into here. So let's use our 20 example, and we'll use 4. So we have 20 people. How many different ways can I pick 4 of them? So we would use our formula, which is CBR equals n factorial divided by n minus r factorial times r factorial. Basically, we're just dividing out all the duplicates, like we talked about on Tuesday. So if we have 20 people, it would be 20 C for our combination. We're only picking 4 of them. So this is going to be 20 factorial divided by 20 minus 4 factorial times minus 4. So what these two divisions do is this gets rid of the duplicate orders. So like if I had those 4 people, I could reorder the 4th person, the 3rd person, the 2nd person, the 1st person in a bunch of different ways. We don't care about those different ways. We're just saying, well, I could pick 4. So this gets rid of those duplicates. This gets rid of all the duplicates for this doesn't get rid of the duplicates, sorry. This gets rid of all the extra numbers because all those extra people. When we're only picking 4, well, our options are, well, I'm going to pick the 20th person, the 19th person, the 18th person, the 17th person, and well, I picked my 4 people, and so we don't need to pick any of the other people, we can throw them away. So that's what this division does here. So this, we could just put this in a calculator, or something simplified. So this is 20 factorial divided by 16 factorial, 1 minus 4, 16 factorial, times 4 factorial. Now because we are multiplying and it's factorial, we can't just combine this 4 times 16 and keep that as a factorial. That'd be way bigger than what 16 factorial times 4 factorial is, because it counts all those different numbers after the first with the factorial multiplication. But what does simplify is this 20 factorial divided by 16 factorial. Right? This can become 20 times 19 times 18 times 17 divided by 4 factorial. This 16 gets rid of all the division or all the factorial multiplication in this 20 factorial. So we're just left with these 4 numbers multiplied divided by the 4 factorial. Okay? And so we could plug this into the calculator and give us some big number. And that big number is 20 times 19 times 18 times 17 factorial 4,045. There are that many different ways to pick 4 people from a group of 20. So yeah, these numbers get really big really fast. But that's basically the whole thing, that one formula, and the fact that we can use these factorial things to exclamation point. Okay? So when we're looking at our student journal, we have these practice problems. 1 and 2, it just says, take all the numbers that are listed. How many different ways can we arrange those? And then how many ways can we pick 3? So combination would be picking 3 of it. We just do factorial for how many different numbers there are. Okay. Number 3 here, we have 9 songs recorded. We're only putting 5 of them. How many possible ways could the 5 songs be ordered? Well, that's just going to be 5 factorial. For the first song, there's 5 different options. For the second one, there's 4, then 3, then 2, then 1, and we just multiply all those together. Okay? And there's some probability mixed in. And this would just be 7 numbers, pick 3. It's a combination. And so we just plug the numbers into the form. Okay, so remember this formula here. This one specifically for combinations. N is the number of things that we could pick. So it's like marbles in a bag. And R is, well, we want to pick 3 of them, or 4 of them. That's how many things we're pulling out. Okay? That's it for today. A bit shorter, again, but it's also our last one. And I will be sending a Zoom invite for next week tomorrow. So tomorrow you're going to get 2 invites, 1 for Tuesday and 1 for Thursday. Thursday grades are due, so you're going to have your stuff turned in by like 2 o'clock, 3 o'clock. So they'll just be kind of last minute things. And that's it. Okay. I hope you have a good weekend, and we'll see you later.